This is a video about graphical inequalities for GCSE. Whenever we're talking about graphical inequalities, we're talking about graphical, which means graph, and inequalities, which means that one side does not equal the other, which means we're going to be using either less than or equal to, greater than or equal to, or greater than symbols in our equations. And because it's on a graph, we have to plot the area that applies to certain conditions. In this case, we have 3 conditions to meet, and what we also have to do, when it says clearly indicate the region, it means shade the unwanted region, and I'll show you what that means in just a minute. The first thing we need to do is just pick one of these. We can choose any at all. Let's just start from the left because it's logical. X is greater than or equal to 3. The first thing you need to do is find out where x equals 3. So here's x equals 3, and we'll draw a line vertically because we know that that is x equals 3 as a line. And the next stage is to find where x is greater than 3. Now that's going to be all of these values in this direction. So we know that the value that we're looking for has to be somewhere above on the right-hand side of that line. So where's the unwanted region then? It's below. When I say below, I mean where the values are less than 3. So we shade everything else that's less than 3 on the x-axis, and that's the first part done. We'll do the next one in green. This is y is greater than or equal to 1. So we need the line that is y equals 1, and here's y equals 1 on the y-axis, and it's going to be a horizontal line this time because y is greater than 1, which means our value has to be somewhere over here. So we shade everything that's not above. Y is greater than 1. We know it's above that line. You can think about it as, actually I'll do this with a straight line first, a non-vertical or horizontal line. So the third one we'll do in red, x plus y is less than or equal to 5. The easiest thing to do here is to put it into the format y equals mx plus c. We won't have an equal sign, but this should be familiar to you as the formula for a straight line where m is the gradient, the slope of the line, and c is the y-intercept. Once we have it in this format, it's much easier to plot the line. So let's rearrange this into this format. We're going to keep the y on the left-hand side. The symbol, the inequality symbol, will stay the same, less than or equal to. Now, instead of just keeping the 5 here and going take x, I am going to put it into the form mx plus c, which means that I'll have negative x first, plus the existing number here, integer, which is 5. So our y-intercept is 5, and our gradient is negative 1. So the first thing to do with these, I find, is the easiest, is to find the y-intercept. Y-intercept is 5, so we just find y on the y-axis, and our gradient is negative 1. So if we're looking for, if negative 1 is our gradient, that is the same as negative 1 over 1. So you may recognize this if the gradient is y step over x step. Then negative 1 over 1 gives us an indication of how many units to move for each. Y step is negative 1, so from 5 we come down 1, negative 1, and x step is positive 1, so we go across 1 on the x-axis. So we can continue to do that, down 1, across 1, down 1, across 1, and of course we could multiply this by top and bottom by any number to get a larger range to be able to plot, but we can see it's 45 degrees. And so bring in a ruler, do this properly, and 45-degree angle from 5 straight down. Now we have to work out where we are going to be shading. So if y, using this manipulated formula, the rearranged version, y is less than or equal to our line, so our value has to be below it, we would shade above. And that is our final shaded version. In case it wasn't completely clear, because it's not, this little tiny triangle is the only piece of this graph where all three of these conditions are met. But that's the completed version of that question. The second question here is very similar, except that we have a slightly different symbol. Here we have less than, not less than or equal to. The only difference here is that when we draw a line, it has to be a dotted line to indicate that the value cannot be on that line. So if y is less than x, we can also think of this in terms of y equals mx plus c. Here, the gradient is 1 and the y-intercept is 0, because it's 1x plus 0 is the same as just x on its own. So if 0 is the y-intercept, then it's the origin where we're going to have our line go through. And the slope, or the gradient, is 1, which means for every 1 we go up, we go 1 across, and 1 up, 1 across, like that. So it's again a 45-degree angle, but upwards instead of downwards. And let's see if we can get this ruler working. Not today, so I'll freehand it. Okay, so that's our first line. Now, as I said to you before, it has to be dotted. It's a little more difficult for me on this iPad, but as long as it's a dashed or a dotted line, you should be okay. And then some shading, of course, we need. So if it's y is less than x, then our value is going to be somewhere down here, and or value range of possible values is down there, so we shade above. It's a bit more difficult with a dotted line, and that's that. Let's do the second one in green. So y is greater than or equal to 1. This is similar to the previous question. If y equals 1, it will be there. And we know that the value has to be greater than 1, so we shade less than when y is less than 1. So here's y is 1. The values down this way are less than that. So we know that y is greater than 1, so it has to be values above that line. And so we've got an unshaded area where there are some possible values. The last one, again, we just need to manipulate so that the y is on the left-hand side on its own. The symbol stays the same. Again, we have negative x where our slope is -1, just like the other one, and 4, positive 4 is our y-intercept. So I'll do this a little faster. There's y-intercept, -1 as a gradient. And it's going to look tiny like the previous one again. 45 degrees. Okay. There we go. And y is less than, so we shade where y is greater than. This is why I was going to use a straight line, non-horizontal or vertical line. If you think about it here, y has to be less than this number on the y-axis. So our unshaded region is actually not very easy to see, but you know, because I've drawn it in front of you, you probably identify it a little easier than if I hadn't. But here is our possible values. I'm going to try and keep that dashed. There's a solid line, and there's a solid line. As I said, this is a dashed line here, so there should be a gap in there. Okay, so the value could be anywhere on these dark, thick black lines, and it can't be on the dashed line, which is on the top left-hand side. And that's those first two calculations. This next one is a little different. Have a look at that, and I'll come back in the next video to describe this solution.